Hello, I'm Evan Hyde with Coking.com, and we are here today on the shop floor at ValvTechnologies in Houston, and I'm here with Justin Weber. Thank you for joining us, Justin.
Good morning.
Would you introduce yourself just briefly to our audience?
Certainly. I'm Justin Weber. I'm an industry specialist here at ValvTechnologies. I focus on refining oil and gas and downstream applications.
Thank you. So we have a couple props in our hands. The subject of today's video is going to be the integral seat on your design, which is, you have a little miniature version of it right there. And we'll go through the details, but you'll notice behind us we have a Coker-specific valve. They've been nice enough to stage for us to give some examples of what this is. And then we're also going to be talking about the live loaded seat, the Belleville washer assembly as well. So Justin, if you would be kind enough just to kind of give us sort of a quick briefing on what that is and how does that work?
So here at ValvTechnologies, our design philosophy is very simple. We've taken what we believe to be a complex valve design where most people are familiar with either a pressed-in or a floating seat or even a spring-loaded seat, and reduced that to just a single sealing face and making it integral to the valve body itself.
Okay.
So we have a single sealing face as part of the body component.
So what you have in your hand there, so you have the one end of the machine valve surface, and then this is the whole seat assembly that kind of comes out, and it's all one piece.
It's all a single piece. We call it an integral design. What it allows us to do is remove 50% of potential leak paths in a traditional seat design. So instead of having one path between ball and seat and the other between seat and body, now we only have to concern ourselves with the sealing between ball and the seat itself.
Okay. And those two parts are lapped together.
Right. So we hard face both of these components and then mate lap them together, and we load them into each other with the Belleville spring.
Okay, perfect. Well, let's step around to the side here and look at the larger valve. So it's always easier to show the little baby demo, but can you just brief us just quickly on what are the different ends of this valve and how can we tell which is which?
Right. So we divide our valve into two major components, being the body and the end cap. And the end cap component is actually where the integral seat is housed.
Okay.
So inherently our valve design is unidirectional. And from here you would see from a right to left flow with the integral seat being here and the ball being loaded into that seating face.
And that's why you have this little placard here?
Right. So all our valves will come with a high pressure tag to identify where the high pressure end should be in your isolation scenario.
And for our Coker-specific audience, what we have to remind ourselves is that the high pressure end is actually in between the two valves, because that's where we build the steam pressure. That's where we want the valve to get pushed into the integral seat, right? So that's something that sometimes gets people a little bit confused, but it's labeled and the instructions are very clear which way to put these things in.
Right. We try to avoid the flow error just for that reason, so operators and installation doesn't get confused where potentially normal flow comes into contradiction with where we need to isolate.
Yeah, especially in our world, because flow goes back and forth both directions, right?
Exactly.
Well, so let's step around one more time, and like you can see with the smaller demonstration piece, this is the fully integrated seat, and here you can see there's the ball on the inside, and this is all one piece of metal all the way to the inside.
Right. So in these designs, we try to make the valve essentially in the open position a continuous piece of pipe.
Yep.
That way there's no convolutions or extra area for coke to potentially hide or build up. Mm-hmm. We want the process media to flow right through the valve without any issues. And when you look down the barrel of this valve, you can see exactly that.
Well, so since we're here, let's take this opportunity to look at part two of this discussion, which is the live loaded seat at the other end. So if you look down at the far end, you can see the seat assembly. And so describe to us, Justin, what this little gizmo is, and I'll trade you.
Sir.
Maybe. That guy. So what is that guy and how does that work?
So obviously not a matching set here, but the Belleville spring allows us to load that ball into the seat with very high pressure. All right. So we describe this type of valve as a seat supported design.
Okay.
Right. So it's not, the weight of the ball is not being held up by a trunnion. nor is it floating between seats, but we actually have the load from this Belleville spring is in contact with what we call either an upstream seat guide or an upstream seat, and then those faces are pressed into the ball, and then of course the ball into the integral seat. That's the sealing face we're concerned with. So as we tighten down on the body bolts, that load is all transferred and helps us to create that metal to metal seal between the ball and the integral seat.
And so this Belleville washer, I know it's kind of subtle, but if you look at it very carefully, you can see that there's a little curvature to it. And this is, in fact, applying that force.
Exactly. So despite what you might think a coil spring looks like, something more traditional inside of your pin, that small kind of unique geometry that makes a Belleville what it is allows us to load this into the valve body and apply force to the valve, into the ball.
And I'm sure many of the operators and engineers that are familiar with, we also use Belleville washers in the stem assembly as well.
Exactly.
It's basically the same concept. It's just bigger, stronger.
Right. Exactly. Same concept. Where here we've got live loaded packing that the Bellevilles allow you to kind of flex on that gland a little bit. Here, this is a static load that keeps that ball in its place. So we're fixing that ball along several different axes inside the valve. So it's always on center, so that way the seating faces are always in contact in the right places.
Oh, perfect. Well, I think this has been a very good introduction to the concepts around the integral seat and the Belleville washer that is unique to the ValvTechnology design. So I want to say thank you to Justin for explaining their technology and joining us on the channel.
You're welcome.
Thank you. I encourage everybody else to watch our other videos about all things delay coking and join us at the conference. And we're here for education, and we appreciate you watching.